Alright guys, welcome to this page of the notes, and you should recognize these. We've been doing them here pretty much the entire year so far in geometry. It's a two-column proof. What we're going to do is we're going to go ahead and complete these two-column proofs using the angle, side angle, triangle congruence theorem. Let's just go ahead and jump right into these. We're already familiar with how they work. And again, what you've seen, we've done this before. You've essentially been given the structure of the proof. If you want, you've been given the bones of the proof. You just got to fill in the missing pieces. Let's go ahead and do that. I've been given this diagram right here. Let's go ahead and take a look at what I've been given, right? And then we'll jump into the proof. Here's what they tell me. They tell me that angle MQP, MQP is congruent to NPQ, Well, let's go ahead and draw that in my diagram so that I know those guys are congruent. MQP, that's this guy right here, right, that angle right there, is congruent to NPQ, this angle right there. All right, let's keep going. I'm told that angle MPQ, okay, so that angle right there, I'm told it's congruent to NQP, Okay, let's go ahead and put that in our diagram. I know that this angle right here, MPQ, is congruent to NQP. Well, fantastic, right? Here we go. So I've got, right, those angles are congruent, those angles are congruent. Here's what they want you to prove. They want you to prove that the triangle on the top is congruent to the triangle on the bottom. Well, I think you can see where this is going, right? Can you see where this is going? I have two angles that I already know. It's been given to me that those pairs of angles are congruent. All I have to do is show that that included side is congruent, and I have angle side angle congruency theorem. All right, let's see how this goes. I need a given, right? It tells me right here in the proof that it's a given, so I need a statement, right? I'm going to write one of the statements that I was given. Well, I've been given two things, right? I've been given two things. So how do I know which one to use? Well, we take a look at the proof, and I've got MPQ, NQ. Okay, so look, this part I've given it's already here, right? So actually now I know two things. Since this was given, this other given has to be the one that I wasn't. So there we go. We're going to be given MQP is congruent to NPQ. That's right, this was given, and I know, right, this was given as well, so number two must also then be, that was given to me. Okay, great. All right, so there we go. I know that I now have two pairs of corresponding angles. All I need to do is show the included side. The included side is also congruent, and we've got it. Well, let's see. Reflexive property of congruence. Here's what the reflexive property says. Please notice I have line segment QP. And I have line segment reflexive property, flip it, PQ. But, right, remember the reflexive property from algebra, right? QP and PQ are the same line segment. It doesn't matter which endpoint you put first and which endpoint you put second, they're going to be the same measure. So I know that these guys are congruent. That is the reflexive property of congruency. And so here's what I now know. I know that line segment QP is congruent to line segment PQ, which means, boom. Right? Obviously that length is congruent to itself. It's congruent to itself. Well, there we go. Angle, included side, angle. Angle, included side, angle. So these two triangles are congruent based on which congruency theorem? Angle, side, angle. And it's just that easy. Let's do another one. Okay, here we go. Let's first go ahead and take a look at what we're given. Fill in our diagram a little bit if we need to. I am told that angle A is congruent to angle C. Let's put that in there. Angle A is right here, and that angle is congruent to angle C, this one right down here. So I know that those two angles are congruent. We're off to a pretty good start. I am also told that E, there it is, point E, E is the midpoint of AC. So I have this segment right here, AC, and I'm told that E is the midpoint. What does that mean? Well, remember, a midpoint cuts a line segment right in half. So that tells me that those two segments are congruent. AE and EC are congruent line segments because E is the midpoint. Well, we're really close here. I have an angle, I have a side. All I need is one more pair of angles, and I've got angle-side angle congruency theorem. Can I show that these two angles are congruent? Well, actually, indeed I can. You should remember back to earlier, we talked about the idea of vertical angles. Well, here they are. These are vertical angles, which means they must be congruent. Two angles that are formed by intersecting lines must be congruent angles, right? That's what the vertical angles theorem says. Two angles formed by intersecting lines, which is exactly what I have. Line AC and line DB. Those intersecting lines are going to form two pairs of vertical angles, both of which must be congruent. So here we go. Let's fill in our proof knowing angle side angle theorem. I already know these triangles are congruent. We just showed it right here. All I got to do is fill in the proof. Okay, well, I take a look at this. I need something that was given to me. Please note I was given two things in the problem. E is the midpoint of AC. Well, they already put that in there, so I know that that is a given. The other thing that I was given was angle A is congruent to angle C. So there we go, right? Angle A is congruent to angle C. That was a given. E is the midpoint of AC. Again, that was a given. Definition of midpoint. Well, the definition of midpoint, right? That's what told me AE and EC are congruent. Those two line segments are congruent. So I know that AE is congruent to CE, right? Those two line segments, my interior side, those two segments are congruent. That's the definition of midpoint. There it is, right? You see vertical angles are congruent. Well, what does that tell me? That tells me that angle AEB is congruent to angle CED. That's what it tells me. So angle AEB is congruent to angle CED. Vertical, right? Vertical angles are congruent. Vertical angles are congruent. There they are. Those are my vertical angles. I know that they're congruent. And look at this. Here's what I've got. Angle, side, angle. I know that these two triangles are congruent because I just proved corresponding angles, congruent. Corresponding sides, congruent. Corresponding angle, congruent. That's angle, side, angle. Angle side angle theorem. Angle side angle congruence theorem shows me, tells me those two triangles must be congruent. Got one more for you here in this section. So let's go ahead and take a look at another proof. We'll start by looking at what we've been given. All right, here's what I've been given. I am told that line segment AB, there it is right there, line segment AB. This is a really important word. Should remember it from all the way back in Chapter 1 when we talked about this. Bisects. Bisects means that it cuts an angle into two equal or congruent angles, right? Well, what does that mean? Line segment AB bisects CAD. CAD. So what I know is that this angle and that angle must be congruent. That's what bisect means. So this guy and this guy are congruent. And, check this out, AB also bisects CBD. CBD. So I know, right, have to be congruent Awesome. Well, angles. All I have to do is show that included side is congruent, and I've got it. Angle, side, angle. Actually, we already talked about this, right? It's the same line. It's line segment AB and line segment BA. But it doesn't matter which endpoint comes first and which endpoint comes second. It's the same length. That's the reflexive property. Anyway, let's go ahead and start filling stuff in here. AB bisect. That was definitely the given. That was given to me. Let's see. Angle CBA. Angle CAB is congruent to DAB. Definition of a bisector. Okay. Since I know these two angles are congruent, definition of a bisector, the exact same thing happened over here, right? Definition of a bisector, CBA and DBA must also be congruent angles. Definition of a bisector. So angle CBA is congruent to angle DBA, right? Definition of a bisector worked for the angles I've got in green, then the definition of the bisector must also tell me the angles I have in red are congruent. Oh, there it is. Reflexive property of congruency. Remember what that means is that line segment AB is equal to line segment BA, right? It doesn't matter which endpoint comes first. So I know that AB, that line segment, is congruent to line segment BA. That's my included side, and so angle, side, angle. It doesn't matter that I prove the two angles are congruent first. Please note that this is still an interior angle, right? It's between the two angles that I proved are congruent. So it is still angle, side, angle. Okay. Here's the deal. What we've done is we've taken CPCTC, which required you to prove 6 things. 3 pairs of corresponding sides and 3 pairs of corresponding angles was congruent, and we have cut that in half with the angle side angle theorem, where all you have to do is show that 2 corresponding angles and the included side of 2 triangles are congruent, and if you can do that, then you have proven that those triangles are congruent. We've essentially cut the amount of work we need to do in half. Had a lot of fun going over the angle side angle theorem with you guys. I really like shortcuts. Anything that sort of requires us to do less work is good for me. I know that you'd like it too. So I can't wait to see you guys next time. Bye.